Now in chain rule is generally used for composite functions. So if you have a composite function, y is equal to f of gx, composite function. Then when you are applying chain rule, so whenever you have composite function, you have fog x. This is like, as you correctly said, is fog x. So when you take the derivative dy by dx or y dash, okay, you take the derivative of the outer function f dash gx, multiply that by the derivative of the inner function. Okay. That's what your rule is. That's what your chain rule is. Now the IB writes this in a different manner. I've written in a form which makes it very easy to understand. The IB is saying that it's writing the same thing, but it's saying that if your y is a function of u, correct? Where u is a function of x, so it's the same thing as writing g f x. Okay, then your dy by dx is equal to, you take dy by du, derivative of the outer function into the derivative of the inner function. But if you write like this, you will understand better. This is the reason for that. So if I take fog x, don't think that way. Now I'll start with the examples. You'll understand better. Y is equal to x cube plus 4 raised to 7. So what will the derivative be? What is my outer function, you think?
1. So
outer function is what? Outer function is raised to 7.
1 raised to 7. Right?
Yeah, some number is, some function raised to 7. Whatever, ignore this. Be blind to this.
So there'll be something.
Something raised to 7. X, like x raised to 7.
But so there's nothing outside, doesn't that mean it's 1?
This is, you don't worry about that. You look at this bracket. This is my outer function.
So isn't it the inner function?
No, raised to 7 is the outer function. Inner function is x cube plus 4. It's your x cube plus 4, the whole raised to 7. So your outer is your 7.
Yeah, that's the power of the outer function. Yeah. Okay.
So what is the derivative of x raised to 7? Like suppose if this was x raised to 7, what you could have done?
6x raised, 7x raised to 6.
So you could have done 7. Don't touch the inner thing. Raised to 6. Multiply that by, what is the inner function now?
3x square plus 0. 3x square.
Into 3x square plus 0. So that means this is 7 3s are 21x square, x cube plus 4 raised to 6.
Once before
Y is equal to 5x square minus 4 raised to 8. Now one way of doing it is you can do binomial expansion and do each term separately.
Okay.
But that will be a big headache.
Yeah.
Chain rule. So you want to try doing this chain rule? Try. Yeah. So as you correctly did, so you outer function, so dy by dx, this will all become automatic as you practice. 8 5x square minus 4 raised to 7. Correct? My outer function. Multiply derivative of the inner function, that's your 10x minus 0. So that's your 80x 5x square minus 4 raised to 7. Okay. Next. 1 upon root of 4 minus 3x.
Wait, so I have a question. What is the question?
If there was a number outside the bracket, leave this as it is. Suppose there's a number 7 over here. So 7.
Oh, and then you just multiply.
Yeah. Yeah. So if there's a number outside, you
that wouldn't impact when the
no, that's a constant. Like your 5x square. When you're taking derivative of 5x square, 5 you're keeping it as it is, and you're taking the derivative of this. So that's the same thing.
7 into 5.
Yeah. Okay, try this. Yeah. So it's very important that you rewrite this first as y is equal to, get in the numerator. Correct? And then when you take the derivative, so minus half 4 minus 3x raised to minus 3 by 2. Derivative of the inner function is minus 3. So basically that's 3 over 2 when you multiply 4 minus 3x raised to. Okay, next. Yeah, so it won't matter whether you apply the quotient rule or this rule. So I'm showing we are focusing on chain rule. So get this on top. Correct? Minus 1 So y dash is equal to minus 4, 3 minus 2x minus 2 into minus 2. So that's 4 to the 8 upon 3 minus. Okay. Now, let's focus on sine. Chalo. Try. You keep your inner function as it is. So,
Okay.
so that means when you're taking the derivative, outer is sine. So derivative of sine is cos.
Cos.
You leave
Also
this
cos 3x.
cos 3x into derivative of 3x, which is 3.
So 3 cos 3x.
Okay. Next. Sine square x. Find the derivative.
My inner is x square, which means my outer
No,
is
no, no,
sine.
no, no, no. Actually, your sine square x technically is. We lazily write it that way.
Okay.
It's sine x the whole square.
Oh, so my outer is just 1. So just square.
Square. So when you take the derivative, what will it become?
2 into
2 sine x. That's your outer function into
cos x.
into cos x.
2 sin x is 6. So,
Sine cube
can't
square.
you also use trig identities for the same thing?
You can use trig identity, write this as sine 2x.
Yeah.
You can write this as sine 2x. Fine. You're just combining that by using trig identity. That's okay. Sure. Next. See, there are 3 layers.
Okay.
Y is equal to sine 7x the whole cube. The outermost function, so when you take the derivative dy by dx, outermost is cube definitely.
Yeah.
This is your powers, very clearly the outermost function. So that 3 sine 7x remains as it is.
Correct.
Now you look at the inner function. Sine 7x. In this, which is the outer, which is the inner?
Outer is sine of x, inner 7.
Correct. So sine cos 7x into, now uske inner is what? 7x. So 7x. So the derivative is 7. So like that there will be layers. You have to, it's like the onion. You will keep on peeling layer after layer.
So I can write it as 21 sine 7x
Yeah,
square.
yeah,
into
yeah. Sine square 7x. Yeah. Okay.
So is that all that's also there in the chain rule?
Wait. Don't be hasty in.
Some got it because I'm not finishing all the.
No, don't worry. It's not the content. It's. Yeah. So your y, you rewrite it as 1 minus sine 4x raised to minus half. So when you take the derivative dy by dx is minus half 1 minus sine 4x raised to minus 3 by 2. Correct? Now we will take the inner function.
Yeah. 1 1.
Correct? So derivative of that is 0 cos 4x into 4. Correct? So all in all, this will become 4 cos 4x upon 2, 1 minus sine 4x raised to minus 3 by 2. 2 2's, and that's your answer.
So I got negative 2 1 minus.
So you have your e raised to this. So if your y is equal to e raised to some function of x, your derivative will be
Same.
e raised to fx into f dash x.
Into f dash x.
So in this case, what will become? So what will your derivative become?
E raised to negative
1 minus 3x square into the derivative of 1 minus 3x square 0 minus 6x. So minus 6x into, so it becomes slightly difficult to see this because your
powers are powers.
x, yeah. So when you take the derivative out of function, so ln is
1 over sine x.
into derivative of the inner function is cos x. So cos x over, so which you can write as cot x. Suppose you had okay, so derivative of this is, so outer function, so you start from outer to inner. So derivative of cos ln 4x, you ignore the inner one, you leave it as it is. Now you deal with ln, so 1 over 4x. Then after that you deal with 4x. Correct?
Yeah. So
Okay, now suppose if you had, listen, look at the next one. Do this. I'll go through it. Now listen, the next thing that you need to remember is if your y is equal to 5 raised to x, find a derivative.
something is x. So 5 is x. 5 is x. Oh wait, no, it's for e raised to x. X.
Now, is there in your formula sheet? What is the derivative of a raised to x? Is there in your formula sheet? A raised to x ln a. Please write it down. Now, this is not there in your formula sheet. You have to blow this up.
Okay. 5 raised to x.
So 5 raised to x.
Yeah, maybe 5
ln.
raised to x ln 5.
Okay. Suppose if this was y is equal to 7 raised to sine 4x. Find your derivative. You have to go till the end. You know that's very important. So don't quit halfway. So that's a raised to x ln 7 into, now sine 4x is cos 4x into derivative of 4x is 4. So that's your answer basically. You can simply write this 4 in front and you can do that. Okay.